simplify. So then the surface area is x squared plus, that's 2, 8, 0, and 1, 24. I think it's 25. Correct me if I'm wrong, please. Is 4 times 62 correct? Good. So divided by x. Of course, we have to differentiate. And this is 2x. Remember minus? When I differentiate 1 over x, 250 over x squared. So, of course, I continue finding the least common denominator. Please remember to multiply. Do not just simply add or... Okay, so this is 2x cubed minus 250. And eventually I have to set this equal to 0. And we know that a fraction is 0 when? When is a fraction 0?
When the numerator is equal to 0.
Very good. So I have 2x cubed, thank you very much, minus 250 equals 0. I move 250, divide by 2, and I like this number because when I take the cube root, I get 5. Very nice. And this is in inches. Will this give us a minimum surface area? I have no idea. I have to study the sign. So x s prime and 0 to, I don't know, it doesn't matter. But of course it cannot be infinity. And this is 0. The denominator is a waste of time to put in values because it's always positive. When I plug in 0, I get negative. When I plug in 10, this will always be positive. Guaranteed that this is the minimum. No question about it. So now I need to determine the height and find s of 5. So what is the height? The height is 62.5 divided by x squared, which is 25, and that will be in inches. And the surface will be 25 plus 250 divided by 5. I just plugged it in. So I don't really need the height, but let's determine it. Divided by 25. I get 2.5 inches. And in order to determine the surface area, so I have 25, and this is 50, so this is 75. What is the measurement unit for this? Anyone?
Inches cubed.
Careful. What do we measure the surface in?
Inches squared.
Very good. So the volume is area of the base, which is inches squared times inches. That's why we get inches cubed or cubic inches. But here we have length times width plus length times width plus length times width, blah, blah, blah. And we get x times x, which is inches squared. Any questions on this? Okay. We can also work on other problems, and you can bring any problems from MyLab Math to class. Whatever you encounter from this section, if there is something new that we haven't done in class, please tell me and we'll do it in class next time. I'd like to move on to 2.6. It's marginals and differentials. This concept looks a little bit weird at first, but if you pay attention, and I'll repeat it as many times as you need, it will not be a difficult concept. But first we have to discuss this. So let's take a look at a function. We used this function a lot when we talked about the difference quotient. Oh, I graphed something similar. That's all I meant. Okay, so here we have that point P, and the coordinates are x, and of course f of x. We discussed that. We also have that point Q, and if you remember, we determined the slope of the secant line, PQ. And of course, this is that x plus h, and this is the f of x plus h. We've seen this several times. Okay. Also, I would like to graph the tangent here. This is the tangent line at P. Tangent to the graph of f of x at P. And I am going to extend this line. And I am going to extend this line as well. And I'm going to create a right triangle here. This now, in the past it was called H. We're not going to use H anymore. H has use for difference quotient. Now we're going to call it two different things. In this case, they are the same. Delta x equals dx. We're just changing the notation, and you'll see why very soon. We're changing the notation. Instead of h, we're going to call it x plus delta x or x plus dx. And they are the same. They have different names, though. So this and this are called delta x is the error, but it doesn't have to be called error, or it can be called as a change. So delta x is the change in x. What could be the change in x? It would be something like, let's say I have a radius of a circle, and it should be 10 inches, but instead it's 10.2 inches. The 0.2 will be delta x. If you want to call it error, or if you want to call it minor change, the 0.2 in this case will be delta x. Now, dx has a different name. Although in this situation they are the same, it has a different name. So dx is called differential of x. How do I translate this so you understand the difference? This is connected to the derivative. That's why it's differential to the derivative. This one has nothing to do with the derivative. It's the actual change. In our case, they will be the same, but this is connected to the derivative of the function. This one is not. Okay. Next, back to the graph. We're going to look at this difference. And finally, one more difference. This one. Where this is the intersection of the tangent line with the vertical line representing x plus delta x going through Q. This is this point. And this point, of course, is the y coordinate of Q. So these are two, the red and the green. So let's talk about the red first. The red is called delta y. And the green, we're going to discover it together. I'm not going to tell you what it is yet. So delta y, oh, that's not good. Delta y is the exact change or error in y value, or y values, or the function better, because y is the function. So delta y is the exact change in the function produced by delta x, the error in x. So see what happens here. If the radius of a circle or a disk that I'm working on has a minor error in the radius, right? That will trigger an error in the area of the disk. So if I have this disk and the radius should be 0.2, I'm sorry, 10.2. It should be 10.0, but it is 10.2. Smaller or bigger, it doesn't matter. It could be 9.8. But if it's not 10, but it's 10.2, then the area will no longer be pi times 100. It will be pi times 10.2 squared, which is not the same. So any error in the radius will create an error, corresponding error in the area. So that's what this is. So delta y is the exact change or error in the area of the disk produced by this error, right? By this error in the radius. And what does delta y equal to? Is f of xy, f of x, now I have to change it here too, dx or delta x. So it's f of x plus dx minus f of x. This width here. It's the delta y. This minus this. So delta y, the exact change, is f of x plus either delta x minus f of x, or you can put the x. Doesn't matter. So this is the exact change produced by, in the function produced by the error. Okay, now let's analyze the green piece. As you notice, the green piece involves this line. Can anyone tell us the slope of this line from what we studied so far in calculus? What is the slope of this line?
Delta y divided by delta x.
Perfect. Delta y divided by delta x, no, because delta y is this. So forget about the graph and the rest of the graph. You know that this is a tangent to a graph. What will be its slope? So the point is x comma f of x, and the tangent here. What is the slope of this tangent at this point? It's f prime of x, right? So if this is the point and this is the tangent, this slope at x is f prime of x. We agree with that, right? That's how we determine the slope of any tangent. We determine the derivative and we plug in this value, right? So the slope of this line is f prime of x. Also, from this triangle, what is the slope of this line? Rise over run. If I have these 2 points, then it's rise over run. So I determine the slope of this line in 2 ways. F prime of x and also equals rise over run. Okay, we're getting to the relationship right now. So f prime of x equals rise over run. The run I have is dx, right? So now together, what do you think is this green piece? What could it be? What could fit in here? There is only one thing that could fit in here. Just look at this and say, I know. And there is only one thing that will go in there from our experience so far. Anyone? Okay, we didn't use this notation that may be enough. It cannot be anything else but dy. So this is Leibniz notation, dy over dx. Maybe we didn't use it enough. I remember using it, but maybe this concept did not sink in perfectly. So f prime of x is the same with dy over dx. But now I'm showing you what these pieces represent. So this green piece is the dy. But what does it mean? So like before, dx involves the derivative. The same thing, dy is the differential of y. What does it mean? It's not the exact change. No, it's the approximate change. Approximate change created by dx, change in f of x created by dx. In other words, using the derivative. If you want the exact change, this is the only one. If you're happy with some minor error and you want to get a quick answer and you are okay with an approximate change triggered by dx, then you will be using dy. Now, final question. If you remember, this point and this point are very close to each other. I had to zoom in to show you what's happening, but they are very close to each other. Q is somewhere here, very close. So this is minor, right? This, in my example, this was 0.2. So this minor change in x triggers a change in y. But now, what do you think the relationship would be between delta y and dy? And that's what we are going to discuss in 2.6, the relationship between these two values, keeping in mind that Q and P are close to each other. So delta y and dy. Delta y, once again, it's f of x plus dx minus f of x, and dy, cross multiply, dy is f prime of x dx. This is this, and this is this. What do you think the relationship between these two is? And then we can look at problems.